We're here today in AeroValve's test lab, and we're going to get you excited about pneumatic directional control valves. The exciting thing about the technology inside AeroValve is that it effectively recycles a portion of the downstream air every time the valve cycles. So instead of just venting that air to atmosphere, it basically allows part of that to equilibrate to the other side of the valve before it vents. And this all happens as a plug-and-play experience for the user during that cycle. So the user can replace their valve with our valve as a plug-and-play. They don't have to reprogram it. They don't have to do anything. They basically just put it in and start saving energy. And in front of you here on the table, we have two valves that effectively are identical, except the one on the right has the AeroValve technology inside. These valves have the similar CV, similar flow characteristics. So the test that we've devised to really fairly compare these valves is what you see in front of us. There's a 5-gallon air tank on the right that's going to supply air to the valves, and that's going to give a specified amount of air, and we're going to use that air to one by one cycle these valves, and we're going to see how much work they can do before effectively they run out of air. So the first test we're going to do is going to be on the left valve. That's the standard valve. So the screen that I'm showing is an Allen Bradley standard screen that would be used to control this type of valve in a factory environment. Our screen has been designed specifically for this test. So we have the starting pressure for this test set at 80 psi. We have an ending pressure at 70 psi. The valve cycle time is set at 1 second for one round trip of the air cylinder, and we'll just repeat this test one time for this demonstration. The second part of the screen in the middle represents the tank pressure that's being measured from the tank that is providing air for the test. And as you will see when I start the test, the pressure will rise above our desired starting pressure of 80. In fact, it will approach 90. And this is in order for us to provide the valve with enough cycles before the measurement starts so that any settling or turbulence in the tank settles out. So it will overfill, start to cycle, and then when the pressure reaches 80 psi, the counter at the bottom of the screen will begin to count, and it will continue to count cycles of work performed until we reach 70, which is our specified endpoint. So I will begin the test. The tank is now beginning to fill, and as I mentioned before, it will fill above 80 psi, probably close to 90. Now the tank is full and the valve is beginning to cycle. When it approaches 80 psi, it will begin the count. Now the valve is cycling and the counter is counting. The counter will continue to count work performed until we hit 70, which is our specified endpoint. And now that's complete. So we've achieved 21 strokes in that test. Okay, so now what we're going to do is switch from using the left valve to using the AeroValve valve. So I'm going to reach back here and we will simply switch these switches, which will now open up the air paths to the cylinder for the right valve to utilize it. Now I'm going to switch to the right valve. The test is going to be set on the same settings as before, and I'll begin the test. So just like before, the pressure is rising. It will overshoot our desired start point, probably to about 90. And now the valve is cycling. Just like before, our counter is not counting work until we hit 80. And now the counter is beginning its count. And it will continue to count until it drops to 70 psi, our specified stop point. And now the test is complete. So on this test, we've achieved 39 units of work with the AeroValve valve technology, and that's compared to 21 units of work that we achieved with the standard valve. That's approximately 80% more work performed with the same amount of compressed air simply by changing to the AeroValve technology.